start with a bit of, we're going to start with a bit of review. I want you to write this number. (45 times 30). I want you to use the distributive property. I'll be coming around to check, and then I'll have someone come up and show us how they chose to solve this problem. And then make sure you talk about what you're doing.
So we have 45 times 30. And then we know that 5 times 9 will equal 45. That's going to be times 10 times 3, because 10 times 3 equals 30.
Yeah, I'll take it from there. Okay, good. So we started by breaking down both numbers, but usually, in most cases, you would just break down the 30, and make it 3 times 10. But I wanted you guys to just break down also 45, so that you can see that sometimes you might be able to multiply by two different numbers. Now, if I take my distributive property, what I just did, I broke it down, distributed the numbers in other places. It's not going to write for me. So I have these two equations. What's the next step I should do? What's the very next step I should do? Well, if we multiplied 5 times 9 and 10 times 3, it would give us this again. So we don't want to do that, because if we did that, there won't be a reason to break down the numbers. But I could have something like this. Couldn't I? So what do I do? Yeah, so tell us what you're doing. You want to wear the headphones? There you go. You'll be all official.
Do you want me to write it up here? Miss Appler, do you want me to write it up here or down here?
Whatever works best for you.
I would do... Can I get the eraser? I would probably do 45 times 10. Well, if it equals, because this would equal 30. I would do 30, and then I would get my answer. Yeah, put 3 over here.
Okay, so everybody help her out. 5 times 3. Everybody.
I carry the 1. 10's a magic number.
3 times 4.
135 is your answer, or if you don't know your multiplication, you can do these ways.
Okay, and then you would take it times 10, which means what do you add to the end?
You take it times 10, so you would add a 0 to the end, so your answer is 1,350.
Okay, and then yesterday, actually it looks like we're still on lesson 1. Sorry about that. 2 days ago, we had a problem like this. So if I wanted to write this a different way, I could say 4,400, or I could say 44. Okay, but what if I just want to say it? I could say 4,400 or 44. What do you think? Yeah, hundreds. Because my last digit before zeros is in which place? What place is that last digit in before my zeros? Huh? So I have these 2 zeros that are, these 2 zeros. Remember, they fill up space. They're just space fillers. And then I have my number over here. So I could call that 4,400 times, where's my last digit? 4. What place is it in? Hundreds. So when I write that out, I would say, everybody, 4. And then it said equals 176. Blank. Now, how do I figure that one out? I mean, they were nice. They gave us the answer, 176, but how would I figure that one out?
By adding the zeros from your original question.
By adding the zeros from your original question, or you know that this is equal to 100, right? Mm-hmm. Or 10 to the power of 2, and this one's equal to 100, or 10 to the power of 2. I have 10 to the power of 2 times. Of course, I don't have my place value chart pulled up that would actually give me the right amount.
You would have, as you put the 2 together, since you have 4 zeros all together, then you would have 10 to the power of 4. That could also.
Okay, so if we put the 200s together, we would have 10 to the power of 4, which would give me which place on my place value chart?
10,000.
10,000. So my answer would be 176. Everybody? $10,000. I think this is getting easier and easier. If it's not getting easier and easier for you, I would say that probably because you're not paying attention while we're doing it. So make sure you're paying close attention. And not something that's across the room or in your desk or in your chair or in the street, in your hair. Yes.
So far, I think I'm understanding everything except when you add the zeros, would you just, like how you had 4,400 times the Oreos?
Whoop. Do the distributive property for me on this. Because we said it was 176 10,000s, right? So how do I get to 4,400? 44 times what? 44 times. How did I get my 2 zeros? I had to go to which place to get 2 zeros? Hundreds, so it'd be 44 times 100 times 4 times, I have 2 zeros again, so what place am I going to? So remember, you can do the commutative property and move the numbers around, and associative by putting the numbers in different parentheses. So that's just for the fun of this, multiply 100 out, okay? 100 times 100. If we do it the old-fashioned way, of course, now I can't even do the old-fashioned way. Okay. 0, 0, 0. 0, 0, 0, 0. There we go. 0, 0, 0, 0, 1. Add them all together. 0, 0, 0, 0, 1. And our winner is 10 to the power of 4. Or what place is that on the place value chart? Everybody. 10,000. Boom. Does that make sense? I like the way you ask questions when things aren't making sense. So I think some of you are learning it's best to ask the questions now, because maybe when you get home, probably unless your parents teaching this math every day, they probably don't really know what we're doing. It's just kind of like, I have to learn it, and Miss Clark will have to learn it. We're all having to learn how to do this. So it's good to ask your questions now, because maybe there's something I'm leaving off and forgetting to teach you, you know? So if you have a question about something, it's very important to ask, so I don't just assume that you already know how to do it, you know what I mean? So thank you for asking your questions. The next number we have is, now we're on lesson 2. It says round the factors and estimate the products. Well, this makes your life easy. Because which number do we round to in these problems? Which number? Which number? The first number, remember that's called front end estimation. So what is the first thing I need to draw if I'm doing estimation?
The vertical number.
Oof, yes. By George, I think you've got it. Vertical number line. Draw your vertical number lines on your desk. This one is going to be representing 656. This one's going to be representing 106. And I want you on your desk to round both of the numbers on your vertical number lines and then show me on your desk what this equation will look like when you are done rounding.
Okay, so since in 656 you have the first number is 6, then you're going to write a 6 at the bottom. Okay, maybe not. Okay, a 6, and then the next number when I'm counting up is 7, so we're going to write a 7 here. There we go. And then half of 6 is 6. And then 5, because 5 is half the way between, and then you're going to put that in parentheses. And then the next number by the 656 is 5. So then, if we have a 5, if we have greater than 5, 5 and greater, we're going to go up. And if we have 4 and under, then we're going to go down. So in this case, we have 6, and then the number is 5. So, and then we're going to put a 5 with parentheses around it. And so then that would equal 700, since we have 5 by the 6 in 656. And then when we have 106, we're going to do the same thing. So we're going to put 1 down here, and then we're going to have a 2 up here, since when I'm counting up, the next number is 2. Then when I have the 1, then 5 is half, so put parentheses around that. And since the next number over is 0, then we're going to put 1 and then put a 0, put parentheses around the 0. So that will stay the same. That will equal 100. And that's how I got the vertical number line.
Good job. So we have, what we're left with then when we round is 700 times 100, and if we did our distributive property, we could take 7 times 100 times 1 times 100, and then we can combine those numbers, right? 7 times 1 times, instead of writing out 100 times 100, I'm just going to put 10 to the power of, what power do we have here? 10 to the power of? Ten to the power of 4, because there's 4 zeros and 2 hundreds, isn't there? So everybody, 7 times 1 is? Times 10 to the power of 4. How many zeros am I going to add? So the answer is 70,000. Now, the way I know that I'm right is because I've learned that if I have 100 times 100, it will put me in the 10,000s place, right? So 100 times 100 is 10,000, and is my answer in the 10,000s place? Yep. Well, today gets even easier. You need to turn to your lesson 3. We're going to start cruising on that. See, the nice thing, the thing that I like now about math is that most of Module 1 is supposed to be review. So that's why it moved so quickly. But now you're getting to stuff that's new for 5th graders. And so I think it goes a little slower and you can actually learn it a little better. Problem set, lesson 3, number 1, 2B10. Not to be continued, but 2B10. Says draw a model, then write the numerical expressions. What is that? What is the word for that? What is the word for that? I just read in the directions. Look at your directions. What's the word for that? This is a numerical expression. And when we're multiplying, the answer would be, anyone know what that is? The answer to a multiplication problem is called a, no, that's addition, sum, product. So it says in A, we're supposed to draw a model and then write numerical expression. Well, we've been drawing their models for a while because their model today is going to be the tape diagram, which I think they're becoming easier, if you ask me. So the question that we have to answer is, doubled. So what do we already know? What do we know? What numbers are we dealing with?
Adding 8 and 7 because the sum equals addition, so we're adding 8 and 7, and whatever that answer is, we're going to times it by 2.
Okay, so we do the tape diagram. And she said we know that we have 8 and 7 and it's doubled. So we'll say part of this is going to be 8 plus 7. And we know we're going to take it times 2. There's going to be 2 of those. So what is 8 plus 7?
15.
So this equals 15, right? If that side equals 15, what does the other side equal? Number 12, what do you think? If that side equals 15, what's this side equal? So what do I have to answer? I have to answer, my answer should have the sum. Well, how do I know what sum is? The answer to an addition problem. What am I going to add?
15.
Yeah, 15 plus 15. So I'm going to say what this whole thing equals. What's 15 plus 15? Everybody?
30.
What's another way I could have written that? What kind of expression could I have written? 12? What do you think?
You probably could have done this 8 plus 7, and then take that answer
Perfect. So this, right here, this thing, whoop, that's the model. This is the expression. So make sure you've done that in your book. If you guys are missing out on easy grades because you're not writing it down. The more you write it down, the more you remember. Yes, sir.
Another way you could get 30 is you add 10 times.
Okay. Yep, you could add 10 30 times, but we didn't know we were going to get 30 yet, did we? When we first read the problem. Good observation, though. Okay. Next question. I guess they're not really questions, are they? Good. Let me leave my bar up. B. 4 times the sum of 14 and 26. It says 4 times. So how many boxes am I going to have within my tape diagram? Show me with your fingers, people. Show me with your fingers, people. Okay, if I have 4 times, I'm going to draw . So what does one of the boxes equal? What is one of these going to be? How much is it going to be worth? What am I going to write up here? What equation am I going to write? Number 3, is it? And it's sum, so am I going to add or subtract? Add what? 26. Raise your hand if you tell me what 14 plus 26 is. 40. How much does each box equal? So I've drawn my model. Now, how would I write a numerical expression for this problem? It needs to involve parentheses. How would I do that? I'm going to do you next. Got it? Okay. Okay. 40 plus 40 times 2, but how do you could do that, but my problem says 4 times the sum of 14 and 26. So I have my model, but play like I didn't have a model at all. What do you think I'd write? No? What do you think? No? Let's try like I don't even have the model up there. What do you think? 14 plus 26 times 4 and 14 plus 26. Numerical expression, guys. 14 plus 26, that's the information they gave us, right? You have to use it. You have to use the numbers that they gave you. So 14 plus 26 times 4. This is my numerical expression. And this is my model. So if they tell you 14, the sum of 14 and 26, You can't change the numbers. You've got to use those exact numbers. And I should have told you that before you started answering, but you pay closer attention if you shoot out some numbers and I say no, don't you? Because like, what? How did I get that wrong? Make sure you write this down, because it's going on. Let me do a big eraser. We're running out of time. Okay. The sum of 3 16s and 2 9s. Raise your hand if you can tell me the information that I know. What's the first thing I see that tells me what I'm going to have to do with this problem? I told you I'd get you next. 3. Okay, 3 what? So how do you think I'm going to do that? And then what do I know? Mr. 27? Or Mr. 17, sorry. You'd be Mrs. 27. Nope, am I done with the problem yet? The sum of 3 16s and 2 9s. How would I write that as an expression? Okay, go for it.
16 times 2.
Hold on. You got to keep it with what the problem says. It says the sum of 3 16s and 2 9s. So what am I going to do with my 16s? What's it tell me about my 16s? There's 3 of them. So how do I write that? What's going to go between the 2? How'd you know to put an addition sign here? Because it says the sum. Okay, we're going to do one more. I want to do E real fast because it's a little different. So the difference between 4 25s. So I start with 4 25s. When it says the difference, does that mean this whole thing's going to add up to a certain amount? No, that means what's going to have to happen is I'm going to have to draw another box below it. That's the same length. I know what to say. I have 4 25s, and then I have 3 25s. What's the difference between the 2? Mm-hmm.
Okay. The one on top of the other has more 25s.
How many more 25s does it have?
It has 1.
So what's the difference between the 2, everybody? 25. So you got to write a numerical expression. 4 times what? 25. And 3 times 25. What goes in between the 2? Yep. Good. It says difference, and the difference is the answer to a subtraction problem, so that would be minus. I'll be giving your homework assignment when we come back in today after band and strings.